Hello Year 7s, this is lesson 11 in the dissolving and separating booklet. We've looked at a number of separation techniques so far. The first one appears to be filtering, the second one seems to be evaporating, and the last one involves a magnet. We'll come on to that in a second. So, fill in the gaps. Fold the filter paper and put into a funnel, double N, full stop. Pour the mixture into the paper, full stop, and a capital letter, the residue is left behind in the paper. And what passes into the flask? That will be the filtrate. Definitely know those two terms, residue and filtrate. Now, boil the salt water in an evaporating dish or basin. That's that, by the way, the evaporating dish or basin. The water evaporates, leaving behind the salt crystals. We did that in the last lesson, didn't we? And the last one here, hold a magnet over a mixture of iron filings and sand. The iron will be attracted to the magnet, leaving behind all the sand. We've separated the sandy iron filings mixture there. Now, separating colours in dyes, a process called chromatography. Okay, let's have a look at a video on this. It's fascinating, it really is. Take a filter paper, using some scissors. We make two cuts. We're making a wick, like a candle wick. Take your ink. Using a capillary tube, a glass tube, take the ink and dab it into the centre of the filter paper, and it spreads out. We now add water into a Petri dish. The water is absorbed up the wick and now it's going to be absorbed by the rest of the filter paper. What happens is the ink particles are dissolved into the water and they move along. Rather, they're taken by the paper, they're taken by the water and they're pushed through and along through the paper. But what happens is the different colours within the ink have different masses, so they move at different speeds. The lighter ink particles will move more quickly. They'll get pushed further by the water as it is absorbed by the paper. And the heavier ink particles are slower to move. Amazing, isn't it? Look at this green, the green one, bottom right. Look how many colours are in that. I think in the green one we've got blues, we've got greens, we've got yellows, and right in the centre we've got even some purples there. All from the original green ink. It's just fantastic. I think with the red one I can definitely see red, but I think I can see pinks as well. Look at the black ink, top right. It's definitely got black inside there, but we've got blues as well, light blues. We've even got like an orange tinge there on the right hand side. And then bottom left, the blue, we've definitely got a bright blue on that left hand side. We've also got turquoise. I think we've even got a sort of light brown there on the inner left hand edge. And maybe even a light purple as well throughout. It's quite phenomenal, isn't it? So here is the sort of method. Number one, yes, cut your filter paper using scissors along the dotted lines. Make the wick. There's the wick there. This is obviously filter paper. Needs to be able to absorb water. Then we've got our capillary tube. That's this here. That's the capillary tube. And we place a spot of ink on there. Could be black, could be green, whatever it is. And then you put your ink dot right in the centre there. Yes. Then you put the paper on a petri dish or a beaker half full of water. This thing here is a petri dish. And you half fill it with water, and then you dip only the wick into the liquid, not the rest of the filter paper there. And then, don't like this table. What's wrong with it? It should be surrounded all the way round, shouldn't it? Terrible. Yeah, put the colours in now. Now, I think I had, for the black, there's definitely some black there. Definitely light blue. Definitely orange. You go back now and have a look at the video and fill it in for the blue and the green and the red. Now, I reckon the red, there was definitely red there, but I think I saw a little bit of pink as well. Now, which ink or food colouring has the most dye in it? I thought that was green, okay? Did, question 2, any ink contain one colour? If so, which one? I didn't think there was one. You might think the red one only had red, but I think there was red and pink in there. So I'm going to say NA, not applicable. Now, we could set up this experiment again, and then rather than using circular filter paper, chromatography, can be carried out using a rectangular filter. So this is the rectangular filter. This one here, there's the rectangular filter. And all you do is add a spot of ink or dye near the bottom and watch what happens. So, how could we use that? Well, here's a nice little investigation now. A fair cop. A man has been found murdered by the side of a road. Police are questioning 3 suspects, but they don't have much to go on. However, during the struggle, the murderer dropped a fountain pen, like an ink pen, and it obviously contained ink. The police have searched the homes of the 3 suspects and have found a bottle of ink in each one. They were very old-fashioned criminals, and they used to use proper fountain pens that needed ink, bottles of ink to supply them. Now, Sample A is from the fountain pen. That was the one found at the murder scene. Okay. Samples B, C and D are taken from the home of the suspects. Find out if any of the inks match sample A. Now we've got a brief description of what went on here, but I wouldn't mind having a look at a video of this. So we're measuring 2 centimeters up from the edge of this paper using a pencil. Now the graphite of the pencil, the stuff that makes the mark, is insoluble in water. So we're putting a mark there and we're putting in 4 crosses. Remember, this graphite will not dissolve. It will stay exactly where it is if it's dipped in water. Now we're going to label this up as A. That's the ink from the murder scene, and then suspects B, C and D. Now I strongly suspect they're going to take ink from the fountain pen found at the murder scene and put it on cross A. That's it. And then it's ink from the bottle of ink from suspect B's house. I mean, it looks identical at the moment. I can't tell those apart. Ink from the bottle of suspect C. They all look the same to me at the moment. They all look sort of very dark blue or black. I can't tell the difference. And then the final suspect D. Adding a bit more from the fountain pen found at the murder scene, so they're all about the same size. So now dip the sheet of paper into water. The water is going to rise up and take with it the ink particles. But remember, the different colours move up the paper at different speeds. The reason that that happens is because the particles, the coloured particles, have a different mass. And let's just see what happens. A looks like a little cat to me, with its little ears right at the top. To me, straight away, it's not suspect. We're looking at A. Look at A. We want the one that's similar to A. It's definitely not D. No way. There's a lot of yellow. There's a little bit of yellow now in B. It doesn't look right. It doesn't look like A at all. Which two match up, do you think? You want the one that matches up with A. It's like a dark spear with 2 little red horns. It's definitely not D. Suspect D. The ink bottle didn't come from there. A was from the fountain pen from the murder scene. Which suspect had the same ink, do you think? Gotta say, I think I know what the answer is. Now, don't worry about that. But what you could do is draw a label diagram of your apparatus here. What you could do is this, okay? Don't know whether this is going to work. Let's give it a go. There's a sheet of paper. You could draw your line across like so. You could write down, that was A, that was B, that was C, that was D. Label that up as A, B, C, D. You could say that the water line was, I think, it should have been just below, shouldn't it? So that was the water line. Had you put the water line above this line here, the ink would have just dissolved into the water itself. Instead, the water's going to seep up the paper now and create these coloured images. Now, I'm just going to do one example, okay? So we've got, you could colour this in, couldn't you? So you've got sort of a blue spot there. It sort of rises up. If you've got colours, that would help. It sort of rises up like that, and then all of a sudden it turns into a much darker colour. Like so. A little sort of spear at the top. But then you've got those very, very distinctive little red horns. Just either side, near the top there. Right there. Right there. You could do a similar thing for B and C and D. Okay? Chromatography. Now then, did any of the pens match the ink found at the scene? Yes. Which one was it? Well, this is my answer, right? Sample A came from the murder scene. Using chromatography, the black ink moved up the paper, and I've used moved. Okay. The coloured ink was soluble and dissolved in the water. So I've got these two words now. Soluble, soluble, dissolve, dissolved. And we've got colours as well, colours. Okay, the coloured ink was soluble and dissolved in the water. And separated into blue, black and red. The different colours moved a different distance from the start point. I've got distance in there as well. Array, distance and distance, but I've still not said who it was yet. The only bottled ink matching A was sample C. So the person living where sample C was found has some explaining to do. Doesn't mean that they're guilty, it means, whoa, how did that ink get into that pen by the murder scene? Now, let's have a go at this. Homework 5. Use straight lines to match the separating technique to its correct definition. Do you know what I'm going to do? I'm going to make this easier. I'm going to label that up as 1, that up as 2, 3, 4, 5. And now I'm going to do exactly the same over the other side. Let's see what we get now. I'm going to look for the easy ones. Oh, used when separating dissolved coloured substances. Ow, that's got to be chromatography. We've just done that today. That's number 2. So number 2's been done. Number 1, used when separating a solvent from a solution. The solvent does the dissolving, yes. The water was removed, leaving behind the salt. Yeah, that's right. Number 3, let's have a look at number 3. Used when separating an insoluble solid from a liquid. So that is filtration, because we're removing sand or mud from water. Yeah, it's the residue bit, isn't it? Number 4, used when separating a soluble solid from a solution. Number 4, that's distillation. We're removing a soluble solid. Yeah, that's our salty water, isn't it? Okay, or our ink, and we're taking away the water, leaving behind the salt or the ink. Yeah, that's cool. And number 5, used when separating a mixture through shaking and settling. I've learned something new today. That's called decantation. Okay, that is the end of lesson 11. Well done.